Hello, everyone. Today I want to show you how AI agents can help speed up early-stage drug research. In this kind of research, the hardest part is often not the experiment itself. It is knowing where to look next. PubMed already has nearly 40 million papers. So the problem is not a lack of information. The problem is too much information. If you want to understand how a pathogen affects host immunity through a specific gene or pathway, doing that by hand is slow and hard to scale. And finding the papers is only the first step. After that, you still need to ask a few important questions. Is the relationship real? What may be driving it? And which findings are actually worth a closer look? So the real question is simple. How do we turn all of that literature into research leads that are structured, explainable, and easy to check? That is what this workflow is designed to do. So now, let me walk you through it step by step. Step 1 is to reduce the noise. This workflow does not begin by running a large model across all of PubMed. The idea is simple. First, make the search space smaller. The system starts with rule-based filtering. It tries to find the content that is more likely to be relevant. For example, it may first look for immune-related sentences. Then it checks for pathogens and human genes. So instead of starting with the full literature set, researchers start with a smaller group of results that already looks more promising. So this is not just a simple keyword search. It is a workflow built for large-scale literature review. Step 2 is to validate the results that are really worth looking at. Once the initial filtering is complete, AI agents take over the next step. The goal here is to check whether these candidate papers really support the relationship we care about. What we want to figure out here is whether there is a meaningful link between the pathogen, the gene, and immune regulation. At the same time, the AI starts pulling that relationship out of the text itself. So the result is no longer just a matched paper, but a clearer structured signal. Step 3 is to map and verify the mechanism. Once a relevant relationship has been identified, the next step is to understand how it works and whether it is truly supported by the paper. At this point, people usually ask a simple question: how can we trust the AI output? That is why the workflow includes a multi-agent verification step. The first agent is responsible for mechanism discovery. It helps extract and organize the relationship. It identifies the effector, the host target, and the relation itself. Another AI agent is responsible for evidence verification. It checks each claims against the original paper. So the result is not just plausible. It is supported piece by piece by the underlying evidence. Whenever possible, the system also links the result back to the original supporting evidence, so that the final judgment remains in the hands of domain experts. Our last step is to visualize and deliver the results. Here is what that final report looks like in practice. On the upper left, the report highlights the top candidates for drug development from the PubMed results. The colors show support levels, so researchers can see both how often a target appears and how strong the evidence is. In the lower left, the report shows a pathogen overview, giving users a quick sense of which pathogens are most represented in the current result set. On the upper right, the report shows the original PubMed text with key evidence highlighted. So after identifying candidate relationships, the system still grounds each result in the source paper, allowing researchers to quickly verify what was found and where it came from. Right below, the table lists match literature records for the selected molecule, makes it easier to compare supporting evidence across papers. On the lower middle, it provides an AI-generated analysis that turns the evidence into a short, readable explanation of the selected finding. On the lower right, it shows a proposed chain of causation, laying out the possible mechanism step by step, from pathogen to immune outcome. Overall, it turns a large set of papers into a more structured and easier to review research workflow. This report also supports fast interactive filtering. For example, I clicked strongly supported in the legend, and the whole report refreshed. Now every panel is focused only on the strongly supported results. After that, I can narrow it even further by pathogen. Here, I selected dengue virus, and the report updated again. On the right, the table now shows two matched papers for this pathogen from 2014 and 2017. Overall, the report helps researchers quickly narrow a large literature set into a focused, evidence-based view. If we reduce the whole solution to one core idea, it is about turning large-scale, unstructured scientific literature into a research workflow that is filterable, explainable, and verifiable. It helps teams identify promising directions faster, explain the underlying mechanisms, and deliver the results in a form that researchers and decision makers can readily use. More importantly, when AI is combined with structured retrieval, mechanism analysis, and cross-validation, it has a much better chance of supporting real scientific discovery. If you would like to see what this workflow could look like in your own setting, please feel free to contact us. We would be happy to prepare a more targeted demo based on your actual use case. Thank you for watching.